Hey guys, Andre from High Performance Academy. Welcome along to this week's webinar. Now, I apologise, we didn't have a webinar last week. We were over at World Time Attack. We only landed about this time last week, so it wasn't an opportunity to put on any webinars last week. We've also got a pretty busy time coming up leading up to Christmas. On this weekend, we are racing in Christchurch. For those who aren't from New Zealand, it's around about 6 or 7 hours to the north of where we are here in Queenstown. And following our racing on Saturday, we've got the final round of our Endurance Championship. I'll talk a little bit about that in detail shortly. And following that, Ben, Scott and I are heading over to the US to visit SEMA. While we're over there, we've also got some other interesting little tasks we'll be completing, which I'll talk about a little bit. We come back, we're back for a very short period of time, and then we head back over for PRI. So pretty busy end to the year, but it's all good because that's going to give us the opportunity to create plenty of great content, which is why we do this. Believe me, we do not enjoy sitting on long haul flights for 12 hours. So looking forward to seeing what content we can create there. Now, last week while we were over at World Time Attack, we generally try and take the opportunity wherever possible to visit a few of the workshops around. And as those who have been following us for a while will probably know, we are good friends with the team from Mainline Dynos. They've supported us really well since we started High Performance Academy, and we do love their product. And something we've had our eyes on for a fair while now is their DYNO Test Mule. Probably not really any easier way of explaining it than that, but to give you a bit of a graphic of what that looks like, let's head across to my laptop screen. So this is what we've got here. It is not a car, even though it kind of looks like a car. It is a ProMod chassis kit that's been welded together. It's fitted with, I think off the top of my head, 572 cubic inch Dart V8, and it's designed purely for testing the ProHub dynos in Mainline's facility. So this thing is never going to see the light of day. You're never going to be able to bolt wheels onto it, which is probably a good thing because it's capable of producing anywhere from about 2,500 to 3,000 horsepower, depending on the sort of boost pressure that it's running. Now, Todd has been working on this now for a couple of years. We've kind of covered it in brief depth a little while ago in terms of what it was, but basically it's got every sensor known to man on it. In particular, one of the things that we really like is that the engine, as well as the three-speed turbo 400 transmission that's bolted behind the engine. Both of those are actually mounted on gimbals inside of the chassis. Now, what that means is that the engine as well as the transmission can actually rotate about their central axis, and this means that they can then apply force to a load cell that is mounted on the chassis. The idea behind this is what Todd wants to be able to do is basically trace the torque being produced at the engine and the chassis, then what's going on through the transmission, then finally, of course, there are also load cells in both of the hubs. So the idea here is you should be able to see a really clear path of what's happening in terms of the torque being produced at the flywheel and the sort of losses that we tend to see as we go through to the rear wheels. And there's a lot of debate about exactly what happens there. So we're going to get some data. Anyway, the reason I'm talking about this is finally this engine was up and running, and we were asked if we wanted to come over and tune it. I'm pretty excited about that. It's been a fair while since I've had the opportunity to get behind anything that's going to produce 4 figures or more. So as well as this, we were going to use it as a basis of a worked example for our high power tuning for our practical standalone tuning course. And I say were because it didn't really go to plan, as often these things don't go to plan. What we found is that the torque converter that's fitted to the transmission was a bit of an unknown quantity, and it was really, really loose. And basically what that means is that as we applied more and more throttle and the engine produced more torque, it just slipped the converter tragically. So we weren't really able to get any representative runs out of it. We still were a little bit excited about the whole thing, and ended up running it through on the wastegate spring pressure of about 15 psi or 18 psi, I can't quite remember now, and all of about 30% throttle. That's about as much throttle as we could give it without it just sitting up on the engine rev limiter. And if we head across to the laptop screen again, this is the result of that. So certainly not short on power potential, 1393 horsepower at the hubs. And remembering that that was only sitting at 30% throttle, and also had absolutely no tune-up in it. It was quite rich, and also we hadn't added any timing. So looking forward to getting back over to Australia. We're hoping to still cover this once Todd has, probably a drive plate would be the ideal there. There's no real need for a torque converter for the purposes of tuning this thing. So a drive plate which takes the torque converter and any potential slip out of the equation. It's the way that I did it in the past when I was tuning some automatic transmission equipped drag cars back on my old Dynapack. Now the reason that those converters are problematic is typically in a drag application we're running what's called a high stall converter, which is where the converter essentially locks up at a relatively high RPM. It makes it really difficult for us to tune the engine accurately because we essentially go to wide open throttle at the start of the run. The engine will just whiz up to 5 or 6,000 RPM, whatever the the torque converter allows, where it'll sort of lock up, and then you sort of sit there for about sort of 5 or 6 seconds of your run until the wheel speed catches up, and then finally we actually see the RPM start to climb. So yeah, that also puts a huge amount of heat into the transmission because anytime there's a high slip rate through that torque converter, it's superheating the transmission fluid. So not real good for anything, and particularly if we don't need to do that, we don't want to be. Now, while we were at World Time Attack as well, as usual, we managed to produce a fair bit of content that will be coming out over the following weeks. One of the things I actually just put up on our Instagram, so we'll head across to my laptop screen. I just want to show you this. This is probably something that isn't that common, but it is the use of a small drive-by-wire throttle body here. I think it's about a 32mm Bosch drive-by-wire throttle, and it's on the charge cooler, intercooler plumbing between the intercooler and the turbocharger. So there's two uses for this. I should just give you some background on this as well. This was fitted to the Global Aircraft Services Mitsubishi Evo, which was running, I think, in the open class. Can't quite remember now. No, pro class, I should say. And this drive-by-wire throttle body is being used in conjunction with the M-Tron ECU that controls the engine functionality in this car. And it serves two purposes. It can be used here as essentially a electronic blow-off valve. So obviously when the driver gets off the throttle, the drive-by-wire throttle body can be opened the same way a conventional blow-off valve will be operated via vacuum in order to prevent pressure building up between the compressor outlet and the throttle body. The more important aspect though is that this is actually being used for surge control, which is quite unique. We've seen this being used in drag cars where really large turbochargers are being run on small capacity engines, and particularly when the turbo is at full boost, and if the driver, maybe the car gets out of shape a little bit and the driver has to pedal the car or short shift it, we run into a problem where when the RPM of the engine drops, the compressor can be forced into surge. These Pro Class and Pro-Am class cars now at World Time Attack, the top competitors, are kind of getting to that same end where the turbo sizing is a little bit marginal for a small capacity engine, so we can get that same situation occurring. And in real rough terms, the easiest ways of explaining compressor surge is that the compressor is essentially pushing out more air mass than the engine can consume, and it causes the compressor wheel to essentially stall aerodynamically. Doesn't stop, I should point that out. We've had a few people questioning that. The turbo definitely keeps spinning. It doesn't spin backwards. Nothing like that is occurring, but it makes it really hard for the driver to drive the car. The car will be really erratic because the turbo is operating, basically it's unstable at that point, and the engine isn't particularly happy about that situation. If you are running the turbo into surge under wide open throttle high boost conditions as well, it can potentially damage the turbocharger, although ball bearing turbos make this a little bit less likely. So anyway, long story short, the M-Tron ECU is monitoring all of the turbo dynamics, turbo speed, compressor inlet and outlet temperature and pressure, and basically it can be programmed so that if the turbocharger runs into an area where it's likely to be surging, that drive-by-wire throttle body will just open slightly to introduce essentially a controlled boost leak. And so this allows the turbocharger to flow the massive air it needs to. The engine's still happy, everyone's happy. We run out of the surge area, and as the engine RPM increases and can consume that air again, that drive-by-wire throttle body can be closed. So a few people on that Instagram also asked, well, why don't we just control this using the wastegate? And fair enough too. You definitely can control surge by dropping the boost pressure sit in that area. The problem with this though is there is still a transient response issue with the turbocharger. So if we drop the boost from, let's say, 50 psi down to 35 in order to prevent surge, when we're out of that surge area, the turbocharger then needs to ramp back up to full boost, and that takes some time. So by using this technique and controlling it accurately, the turbo speed's maintained. When the engine gets out of that surge area, the drive-by-wire throttle body can close, and instantly we've got maximum boost straight away. So just something that I thought was quite interesting, and we haven't spied on any of these World Time Attack cars so far, although generally these are pretty well hidden down behind the front bar assembly, so probably a bit lucky that we managed to catch this one. I did also notice that the Tilton Interiors Evo was running essentially exactly the same thing. We are racing again this weekend, as I mentioned, in our V8 powered Toyota 86, and as usual there's been a fairly frantic amount of activity happening over the last few weeks since our last round of racing. So I'll just cover off a few of the main things that we've been dealing with. So I'll head across to my laptop screen, and this is number one. Basically, we pulled the diff apart because we were going to make some changes to the tightness of the LSD. We weren't actually expecting to find anything else in there, but as you can see, it is not looking as pristine as it once did. So we've broken the tips off a number of the teeth on the crown wheel there. Interestingly, the pinion gear was actually still looking quite good. Now, this is a little bit tricky to say what's actually caused this. We've had a new crown wheel and pinion fitted. It's something that I don't really like to get my hands dirty with because it is really tricky. You've got to get the mesh between the crown wheel and the pinion just right, as well as the preload on the gears. It is a job that I believe should be left to a specialist who knows what they're doing, and that's exactly what we did. And that specialist who set this up for us, our new one up, said that he believed that the problem was the previous engagement of the teeth was incorrect, and it was essentially running on the tip of the teeth, which is refreshing because we didn't really want to hear that the problem was a result of us overpowering the diff. It is an R180 diff, so we should be pretty comfortable with the 450 odd horsepower that we're putting through it. So a little bit of unexpected maintenance needed on our differential. At the same time as well, we have been battling some fuel system issues, and this is tricky because we are still predominantly running a factory fuel system in terms of the factory tank. That gives us one challenge in that we only have a 50 litre tank capacity with the factory Toyota 86 tank. We really need to be around about 80 litres give or take in order to get through a 1 hour race at pace. So obviously we need to do a pit stop to fuel the car. That's not a big deal because in our 1 hour endurance race we also need to perform a driver change. So the driver change takes longer than the fueling, so that's not the end of the world, but the problem is more along the lines of with the factory tank, we really can't run that down to absolutely empty. We can only run down to the point where we've got about 13-14 litres left in the tank, otherwise we start running into problems with surge, despite the fact that we did have an external surge tank. Now that setup was a little bit marginal as well. It's quite a small surge tank. It was also mounted horizontally, so we don't believe it was particularly effective, and again, this is just how we inherited the car. So we have just gone to the trouble, I say we, but really it's all been Brandon. He's just mounted up this radium external fuel surge tank. So this has 2 in-tank pumps in it as well, probably overkill for our purposes right now. We can control whether we're running 1 or 2 pumps, and that'll all be controlled via our power distribution module. We're actually going to be using that as a reserve or a safety, so if we have a failure of one pump we can switch to the other. So the other aspect with this is it's not just the surge tank, so we've got more capacity there than we previously had in the old surge tank. This is now, as you can see, mounted vertically, makes a lot more sense, so that's all good stuff. We're still going to get the fuel out of the factory tank and up into this surge tank, and that's where we've found with our development of both of our Toyota 86s, the factory fuel tank is garbage in terms of once you get out on a racetrack. With both of the cars, originally we could only run down to about half a tank of fuel before we started running into problems with surge. Obviously that external surge tank in the V8 powered car has helped but hasn't fixed it. So what we've done is, this is a really terrible photo but it's the best I've got here, while we were getting parts out of Radium, we also got their kind of built-in surge tank component that goes inside of the factory tank. And I actually had meant to get their website up so I could sort of talk you through it, but I haven't done that, so I'll do my best. Essentially what this is a two-part CNC machined aluminium tank component that goes inside of the factory tank. You drop it down through the opening in the top of the tank, and then it sort of assembles inside of the tank. So this is sort of a surge tank component, and what it does, it's got a little two one-way valves that allow fuel to flow into that sort of container but not flow out of it, and then obviously the pump sits inside of there. So normally you'd fit one of those to the side of the tank that has the main pressure pump in it. The other side is a suction or scavenge from the passenger side of the tank. In this case we've actually fitted one on each side with a pump. So what we're hoping this is going to do is allow us to do a better job of getting all of the fuel out of the factory tank, pumping it into that surge tank. So of course time will tell, and we'll see exactly how that all works. We've also been working on some sensors going into the car. I've talked in our previous pre-shows about the fact we've just got hold of some izzeracing tyre temperature and tyre pressure monitoring sensors. So these include internal tyre carcass temperature and external tyre temperature. We're going to be using those to help us optimize our pressure and alignment settings. Another thing that we're going to be adding here, we've got a Cyvex 50 Hz GPS and IMU, or inertial measurement unit. So this is the brains behind that little system. So this is going to be sitting basically on the transmission tunnel in the center of the car. So it includes a 3-axis G sensor, so longitudinal, lateral and vertical G. It also includes a 3-axis gyroscope, so we can measure things like pitch, roll and yaw. This works as well with an external GPS antenna. These can be a little bit tricky as well, because a lot of the systems have a relatively short length of cable on the antennas. We see these quite regularly fitted inside of the car, and in general they do a pretty adequate job. However, one of our local tracks, there's a very long corner which is quite shielded by trees around each edge of the track, and we find with our GPS antenna currently sitting in the base of the windscreen that we do have some GPS dropout around that particular section of the track. Whether you're going to get GPS dropout is going to depend to a big degree on whereabouts in the world you are, and essentially how many satellites the GPS antenna has access to. So may not be a problem in an area where there are lots of GPS satellites overhead. So this one is remote, allows us a little bit more flexibility on where it's going to be mounted, and in this case we're going to be mounting it directly on the top of the roof. It is magnetic, so that makes it nice and easy to mount to a steel roof skin, and then that just plugs into the IMU unit. Now, despite this is a Cyvex product, obviously really easy to work with Cyvex or Life Racing ECUs. However, as is common now with a lot of these aftermarket sensors, this does communicate via CAN, meaning that as long as you've got a CAN-based device that has a flexible template for receiving CAN messages, you can set this up into just about anything. So we're going to be inputting that into our wtac C125 dash. Now, on top of that, the other advantage with the Cyvex GPS is the fact it is 50 Hz. Commonly, you're going to find most of the garden variety GPS antennas that are commonly used are probably around 10 Hz. So 50 Hz gives us a lot more data. One of the reasons we want to try that is at a later point we want to see if we can make 50 Hz GPS work effectively for traction control in lieu of an actual wheel speed sensor. But we'll see how that all goes. So car is going to be hopefully loaded up on Wednesday night, Thursday morning, and on Thursday we'll be trekking up to Christchurch to get set up and test on Friday. So hopefully the final event of our season goes well. As I mentioned at the start of this pre-show, we are headed off to SEMA on Sunday, and we're actually going over a few days early, and one of the reasons we are doing that is we're going to be flying into Texas, onto Houston, driving through to Austin, and we're going to be hanging out at COBB for a couple of days. And we're going to be filming some worked example material for our practical reflash tuning. We've been asked quite a lot for COBB material, so this will be specifically on the Subaru platform, so pretty excited to get that shot and out there into our practical reflash tuning course. At the same time, actually also working on another worked example that's going to be going into our engine building, practical engine building course, and we've been having a lot of people scream out for or LS based content, so we are obliging. So we'll head across to my laptop screen. So we are putting together an LS1. This is going to be running a stroker kit. We've got a K1 Technologies chromoly crankshaft, which is what you can see there on the screen. We're also going to be running a set of K1 Technologies forged H-beam rods, and those are matched to a set of wiseco forged pistons. This is a naturally aspirated build, so we've set our compression ratio at about 11.5 to 1. At this point as well, we're not getting too crazy with it because we are retaining the stock LS1 cathedral port heads, albeit with a decent sized cam, but those cathedral port heads basically with the stock valves are going to be our limiting factor. At a later point, if we want to get a little bit crazier with this engine, it would be easy enough to bolt on any of a number of the aftermarket heads that are available though, or alternatively have our cathedral port heads ported. So that currently is about halfway through our build. Now I just wanted to show you something as well. This is one of the aspects of building any performance engine that you do need to be always looking at the parts that you're dealing with and basically looking for any defects or any problems that exist. And when we started this project, we struggled to find a LS1 that wasn't crazy money here in New Zealand to get started with. I know for you guys in the US, they're probably a dime a dozen. You probably have to kick them out of the way every time you walk to the wrecking yard looking for parts, but that's not the situation we face here in New Zealand. So we actually have to pay quite a lot of money for a good quality LS1. We managed to find one that maybe we were told it was maybe a little bit better condition than it turned out to be. This was the dirtiest engine that I've ever seen, and as is quite common when you're dealing with wrecking yard motors, sometimes there can be some more damage that you're not initially aware of. This engine looked like it had been sitting with potentially some moisture in a couple of the bores for some period of time. One of the problems with the LS1 block is that the factory liners are so thin that essentially it's not really viable to bore them out, which we'd normally do. We'd normally go 20th hour, half a mil oversize, allowing us to machine away any wear or any markings in the bores and start with a fresh bore. So we'll head across to my laptop screen, and this was the result after we got our engine back from Hogan. So we can see that there is some pretty ugly looking rust marks in that bore. Now, if I was building this for a customer, or I was building this for something where I really wanted to be absolutely 100% confident that everything was going to go seamlessly, I would probably at this point throw that block away, relegate it to the junkyard again, or use it for something lower powered. In this case, because it's an in-house build, we're not really too worried. That damage there is more visual than anything. So particularly if you run your fingernail across that surface, you can't actually feel any of that ugliness there that you can see. So it's definitely not ideal. As I say, not something I'd be sending out the door to a customer, but these are the sort of things that we do need to be really mindful of. And if you don't keep your eyes open, obviously this one is pretty clear, but if you don't keep your eyes open when you are examining all of these parts, it is really easy to end up with something that's going to affect the engine at a later point, and it's always going to be cheaper and easier to address it here at the start before you've actually gone and assembled the engine. So that's something you probably should expect your engine machinist to bring to your attention as well. So hopefully we're going to have the LS worked example added into our practical engine building course library before the end of the year. Just juggle the filming of that worked example with the rest of the trips that we've got going on as well. So hopefully we can get that done. Now, I have talked a little bit about, nope, sorry, I'm not going to talk about that yet. I'll get into that in a second. Just something we have just released over the weekend, and we've done this a couple of times in the past already. We have released a 2019 VIP deal. So for any of you out there who are currently interested in learning with High Performance Academy, this is a great way of learning with us. This is the best value for money package in terms of getting access to all of our courses. I just want to tell you exactly what a VIP deal is. So basically what you do is you pay a one-time sum of money, and that's going to give you access to every single course that we've already produced, and it's also going to give you access to every course we produce in the future. You're actually going to get priority access to any of our future course releases. You're also going to get lifetime access to our online community. So that's our our webinars, which we're about to jump into shortly, as well as our private members only online community. So if you are interested in learning, learning with High Performance Academy, this is a really cost-effective way of doing so. Of course, it's not going to be for everyone, so really what you need to do is consider what sort of subjects you've seen that we cover that you're interested in learning from, and then also look at what we've got coming up in the future. So if we head across to my laptop screen for a moment, I'll get the team to drop a link into the comments that you can follow here. So there's a little video that covers this off, as well as you can learn everything about it. Now, there is a one-off fee, as I mentioned. So this is $1,597 US. You can pay for this in one lump sum, or you can also split the payments. Because we know this is a fair chunk of cash, we've been quite generous with the way you can break this down, and you can pay that off over as many as 16 weeks, bringing it down to just under $100 US a week. So what you are going to get access to at the moment is all of our courses that we currently offer, free access to all of our future courses. So currently we've got 17 courses. Don't have the numbers in front of me right now, but I think right now that alone is somewhere around about $2,600 US worth of value. The courses that we've got scheduled for the moment, in terms of what we're going to be producing, there's around about $2,500 US worth of value going in there as well. You're also going to get an HPA t-shirt and sticker pack, just to show our appreciation for you getting involved and supporting us. And as an added bonus as well, we're also giving VIP access to our sister company, which is Racecraft. For those who don't know what that is, again, I've talked about it briefly over the last few webinars, but Racecraft essentially is a carbon copy of High Performance Academy. It looks the same, it feels the same in terms of our website setup. However, Racecraft covers vehicle development, race driver education, and data analysis, things like that. Basically, how to make your car go faster if you're interested in going to the racetrack and cutting laps, and rather than actually building your own engines or tuning, etc. So very similar, but in a different area. We've just released our first course there, which is our wheel alignment fundamentals course, which will show you how to perform string wheel alignments with some pretty cost-effective equipment. Now, that is only our first course with Racecraft. We've got a lot of really great content coming up. We're already in the process of writing our next course, which is our race driver data analysis course as well. So I've got all of the current courses there, as well as our planned courses. So again, I'll get the guys to drop a link in here that you can follow through and actually read in your leisure, rather than me talking about everything. So check that out. Now, $1,597 US. If you are already in a situation where you have purchased from High Performance Academy, you should have already got an email from Ben. And basically, we don't want to leave you out in the cold. If you've already spent a chunk of cash, it can be a little bit daunting going, oh, well, I've already spent, let's say, $400 on courses already, and now you've got this VIP deal, which I would have bought if I knew about it to start with. Well, we want to help you out there. So depending on how much you've spent, we've got a couple of coupon codes. Again, you should have got an email. If you haven't, hit up support@hpaacademy.com, and you can use that coupon code. That will bring down that cost, just to basically get you on an even playing field there. So if you are interested, again, this is the best way of learning with most cost-effective way of learning with High Performance Academy if you think you're going to get involved with a lot of courses. We do have a relatively limited number of spaces, and we do have a relatively limited amount of time that this offer is running for. So if you are interested, you do need to move relatively quickly. Like with all of our courses, we still offer our 60-day money-back guarantee, and as with all of our courses, if you use our payment plan, you don't need to wait 16 weeks to start learning. You can get stuck in and start learning as soon as your first payment has processed. All right, and last but not least, we are running currently a giveaway for our Racecraft sister company, which is a BG Racing string wheel alignment system. So that really complements their motorsport wheel alignment fundamentals course that I just mentioned for Racecraft. So I know that's not going to appeal to all of our HPA members. Obviously, there is a bit of a difference there in the kind of information that is being delivered, but if it's something that you think you could benefit from, I'll get the team to drop a link for that giveaway that you can follow to get your name into the draw. All right, that covers everything, I think. So thanks for watching. Give me a few moments and we'll get started with today's webinar.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.